Hello everyone, I'm Siddharthan. In this video, let's build a document question answering RAG framework using the newest LLM DeepSeek-R1. So for this particular task, we will be using the 70 billion distilled version that's available in Groq. But if you prefer having your LLM in your local machine, you can go with Olama, where they have also provided with different sizes of this DeepSeek-R1 model. So we have 1 billion, 7 billion, and other different weights, and we also have a separate DeepSeek LLM that's suitable for chat as well. So you can go with that. But for our case, we'll be using this DeepSeek-R1, which is the reasoning model for our RAG system. And we will also be creating a user interface using Streamlit, where the user can upload a document and we kind of use this LLM DeepSeek-R1 in order to answer this question. And we will also see how this reasoning model is able to think through the question, look at the context, and how it is able to answer that. So we can see that detailing. And for vector DB, we will be using Chroma DB in this case. So apart from this LLM itself, right? So it's good if you are like new to this space of GenAI, RAG, and so on. So you can get a good understanding of all these system work and how you can build one of the system by yourself. So this will be the agenda for today's video, and let's get started. So this is the official site of DeepSeek. As I said, we'll be using the Groq version, so you can search for Groq models over here. But you can kind of go through this to look at like what are all the different versions they have given and also the benchmarks that's provided over here, right? So that's other thing. So I'll be doing my programming part in PyCharm, but you can do this in VS Code as well. So that's completely fine. So any IDEs of your choice should be good. So as I said, I'll be using PyCharm, and here I've created a project with a virtual environment, and I hope that you already know that. If not, you can find the link of my video where I explain like how to install PyCharm on your machine. So that can be useful to you. So here we have a virtual environment specific to this project so that it does not conflict with some other projects that we are creating, so that the libraries that we install here is confined to this particular project alone. So that's the first step of creating your new project with a custom virtual environment for this project. And then we have this requirements.txt that has like all the libraries. So we have LangChain and LangChain community. So we'll use this to create chains and basically orchestrate the entire process. And then we have LangChain Hugging Face because we'll be using the embedding model from Hugging Face. So we have this LangChain Hugging Face combined library, and then we have LangChain text splitters in order to split your document text, and then we have unstructured PDF in order to extract the data, extract the text from the PDF file. If you are using document, if you're using a Word file or something, you would need a different extension of this unstructured, but we are going with PDF. So I have this unstructured PDF over here, and then we have LangChain unstructured, which is the combined version of this unstructured and LangChain. So that would work pretty well. And then we have LangChain Chroma. LangChain Chroma is to basically create that persistent vector DB for us. And then the next one is LangChain Groq in order to load the Groq models. And then we have Streamlit, of course, to create the user interface. And these are the versions that I'm working on. And the Python version that I'm currently in is Python 3.12. So the first step that I'm going to do is install the libraries that are mentioned here. So we need to do a pip install. So I'm opening my terminal, and as you can see here, it says VENV. That means my virtual environment is activated. But in Windows, sometimes when you open your PyCharm, this may not be activated. So how this would look like is, I'll type in this deactivate. So this is how it would look like. So it won't say this VENV or the name of your virtual environment here. So instead it would say PS, which is in your PowerShell. So this is what you would see. But you cannot run your pip install, because when you run your pip install here, that's going to install your libraries in the global part. So we don't want that. We want to install it in the virtual environment. So for that, we need to run this command called as venv scripts activate. So that's going to activate my virtual environment. So I'll paste this in this terminal and run this. And now here you can see this venv. That means your virtual environment is activated. So I can clear this. And the next step is do a pip install space r and say requirements .txt. So pip install r-r requirements.txt is going to go through this requirements.txt file and install all these libraries that we have mentioned along with the versions that we have over here. So that's the thing for this. So I've already installed this, so it's going to say requirements already satisfied for me. So that is the first step that you need to do. And there is another very important part here. So when it was installing this LangChain Chroma, right? So I was getting some errors that we need Microsoft C++ build tools. So you may also face that error if you have not like installed any of these libraries before. So what you have to do is we have to go to this Microsoft C++ build tool. So download the build tools and then install it from the installer. So this will download the installer, and from that you need to install the build tools. So once that's done, you won't get this error while you're trying to install LangChain, Chroma and other stuff. So that's like another important thing that you can take care of. Again, this is happening in this Python 3.12 version. So make sure that if you face that error, you're installing C++ build tool. So that's other thing. So now I'll clear this. Now we can get started with the coding aspects. So I'll right click here and create a new Python file, and I'll call this main.py. So main is usually like the conventional name that we use for our application code. So this is the place where we are going to keep our Streamlit code, and all the other part of the code like processing the document, extracting the text, creating the vector DB, and the next step of getting the answer, calling the LLM, all those will be modular. So we would put that in a separate Python file and then import it over here so that we can keep our code modular. So that's the idea. So first let's import this OS library. So we need it in order to access some folders and directories and files. And then we'll import Streamlit as st. So these are the two libraries that we need. The next thing is, here you can see that I've given a space. So the reason is, the usual standards is that all the pre-built, pre-installed libraries, we mentioned it in the first part. So if there are like libraries like JSON, we kind of mention all these things, give a line space, and then mention the libraries that we have installed separately. So say for example, these are the libraries that we have installed separately. So you can put a single line space over here and mention all these things. And if you have specific modules, so now we will create another Python file and import it later. So those things you can give another line of space and then mention it over here. So that is a standard that you can follow in your code, so that it's very structured. And also you can make sure that you are adding like appropriate comments wherever possible. So that's the first step. So here we have imported OS and Streamlit. And now what I'm going to do is set the working directory. So here I'm going to say working underscore dir. I don't need this one. So working directory is equal to os dot get cwd. So cwd stands for current working directory. So the reason is, we need the path of this DeepSeek Groq rag env, right? So basically it gives the directory where this main.py is present, or basically where your script is running, so that later when the user is uploading the document, right? So how this Streamlit app will be is like, we have a file uploader widget. So the user uploads a file. Now we save this file, convert it, or basically extract the data and create a vector database, and then we pass it to the LLM, right? Now we need to save the file. So that's like one of the initial steps. While doing that, we need to mention the entire path where we want our PDF file to be saved. One way to do this is, you can manually kind of like copy the entire path and you can paste it over here, but it's not a good practice to hard code your path. So instead, we programmatically getting the current working directory, which is this project directory, and then later mention that this is the place where I want this PDF to be saved. So that's the reason that we are doing this. And the other advantage is, if I hard code this file path, right, when you are running this code, you have to change your file path according to your directory names and so on. But when you do this, you don't have to do that. So all those are automated. So we dynamically pick up the directory based on our particular file by getting this current work directory. So that's about it. So that's the first step, and this is another reason why we needed OS library. And the next step is, I'm going to give a title to my Streamlit page. So I'm going to call this as DeepSeek-R1 document track. So Retrieval-Augmented Generation, this is the name, and maybe just I'll add a emoji there as well. So I'll go to this emoji DB. Again, this is not a mandatory thing, but we know that DeepSeek's logo is kind of a whale or something. So I'll just like search for whale over here and just like copy this emoji. Again, this is not mandatory, but just that's a good looking thing over here. So we have title as DeepSeek-R1 document track. And now we are going to create a file uploader widget. So I'll call this file uploader widget. And here I'm creating a variable called as uploaded file, which is equal to st dot file uploader. And within that, within this parenthesis, I'm saying upload a PDF file. And then I'm passing this parameter called as type, which should be a list, and saying PDF. So basically what we are doing is, for in this particular application, right, we are allowing only PDF files. But if you are working with documents, doc, extension, the Word documents and other stuff, you can mention those things here as well. This particular file widget would only allow you to upload PDF files. So that's what we are mentioning here. The type that we are expecting is a PDF file. So first we have created a title and created a file uploader widget where the user will upload a file. And now the next thing that we are doing is once the file has been uploaded, we need to save this file to this particular project directory. So that's the next step. So I'm going to say if uploaded file is not none, in that case, what you need to do is define save path, and then this save path is going to be os.path.join, and we need to join our working directory. The next thing is uploaded file dot name. Okay, let's try to understand this. Maybe I'll just complete another line of code. Save the file. So with open save path wb as f dot write uploaded file dot get buffer. Okay, let's try to understand this. So we have this file uploader widget where the user is going to upload this file. Now once the user has uploaded the file, we need to save this PDF file. So that's the purpose, or that's the step this particular piece of code does. But look at this if statement. It says if uploaded file is not none. So what this basically tells is when the user has uploaded something, the uploaded file as that particular file content, right? So that file is basically, you can think about it as like the uploaded file has been stored in this variable called as uploaded file. But before the file has been uploaded, uploaded file is a none. Okay, so this if condition will run only when this uploaded file is not none. Okay, so understand this clearly. So before the user is uploading something, uploaded file is none, but here we are checking if uploaded file is not none. So that means before the user has uploaded a file, this part of the code won't run at all. But once the, by the moment the user has uploaded something, this is not none anymore. So now this if condition is satisfied and we run this if block code. So what we are doing in this if block code is we are mentioning what's the path where the file needs to be saved, and then we are writing the file to that particular path. So if you look at this, we have this os.path.join, so working directory uploaded file.name. So what we does is, so working directory is nothing but if I go here and copy this path, absolute path, so this is the value of your working directory is going to be. And now I'm joining this with uploaded file dot names. Let's say the user is uploading a file called uh, you know something like book.pdf or something. This is the name of the file that we are uploading. The user is uploading. We can get the file name by using this uploaded file dot name attribute. So now we have this working directory and the name of this file called as book.pdf. When you pass these two things to this os.path.join, so it's going to, let's say, connect these two things, join these two things, and give your entire path of the file. So this is the path where we intend our file to be saved. So in this particular project directory. So that's why we have mentioned it over here. So get your working directory from this get cwd and get the name of this file. So join this and then save in this particular path. Again, we don't want to hard code this, so that's why we are taking this particular route. So once we have the save path, we are saving this using this with open, write this file, and then like use this get buffer thing to just like write this file. This is like a simple step of saving a particular file. So this is that particular step. So now what I'm going to do is uh, also create another widget. So this can be a text widget, or maybe I'll say this text widget to get user input, or basically user question. So how this would work is the user would upload a document and then they type in the question that they want to ask from the document. So for that we need a text box, right? So this is for that. So I'll create a variable called as user underscore question, which is equal to st dot text area. And now I'm going to mention ask your question about the document. Okay, and then I'm going to create a button called as if st dot button answer print, or let me put this as st dot success. This is just placeholder. You don't have to look closely here. So st dot, this is the answer. Okay, so we still need to process this document to store that in the vector db, and kind of passing that to the lm, so that's still there, but I just wanted to show you how we are working on the outline of this user interface. So maybe I'll run this first and now you will understand. So in order to run the Streamlit app, this is main.py, right? You can open your terminal. You cannot run it directly from here, so that won't start your Streamlit app. So instead you need to say Streamlit, make sure Streamlit library is installed. So we have already mentioned that in the requirements file, so we are good. So say Streamlit and mention a run space main.py, which is the application code that has the Streamlit user interface thing. So run this. So that's going to open your browser automatically. So this you can just press enter. They ask for your email, but you don't have to give that. So when you run this, now that's going to open my localhost 8501 port. I can maybe reduce the zoom if I want. Yeah. So I have this localhost 8501. So this is the part where my application is running. And then I have DeepSeek-R1 document track. And this is the upload a PDF file. So the widget that we have created, and this is the question, right? So here you can see we have this title, right? So this title is coming from this st.title, and then we have this upload file st.file uploader. So this is represented by this file uploader widget. You can see this upload a PDF file. So this particular text we have passed it over here. So upload a PDF file. So the text that it should display. And again, we have not uploaded anything, so it's not saving anything. So this if block won't run at all. And then we have this user question text area, right? So this one represents the text area. So and then we have a button called as answer. So we have this button that is clickable. So once we click this, it would just like display that this is the answer. But later we would replace this with the actual code. But what we need to first test now is once the user has uploaded a file, it should save it in this particular directory. And then we have to ask this question. So that's the idea. So this is the file I've been using in order to test this, right? So attention is all you need, which is the paper that Google has launched regarding transformer, and you know what happened after that for LLM space. I'll just like use the same PDF. I think I have this PDF already. Maybe I'll check this. So I'll click on this browse files. Yeah, I already have this attention is all you need PDF. So yeah, now it says the name of the PDF file. As this has already been uploaded, the if condition would have been satisfied and we would have saved the file. So I'll open my PyCharm. Now you can see this PDF over here, right? So this is what we are basically doing in this particular step. So when the user has uploaded some PDF file, we need to save this in the project directory. And then they ask a question, right? So what is this document about? So ideally, now we need to process this document to store this in a vector DB and then pass that to the LLM along with this question, and the LLM would answer your question. Now it says this is the answer because now we have pre-configured this as the placeholder. So this is how this entire thing works. The user upload a PDF, ask a particular question, and click on this answer button, and we call the LLM and we display the answer. So this is how the entire thing works. So now we need to work on how we are going to process the document and how we are going to kind of call this LLM so that we can get a response. That will be the next step. So we would put that code in a different file so that, as I said, we keep the things in a modular way. So I'll maybe just keep this st.success for now. In order to stop this, come to your terminal and press Ctrl C. That's going to stop your application. You can clear this. Now if I come back to my Streamlit app, that's going to say it's not working. See? Yeah, because we have started the application. So now we have, let's work on building this vector DB from this document, and you know how to use this LLM thing. So I'll close this terminal and right click here and create a new Python file, and I'll call this as rag underscore utility. Okay, so this is going to have two parts, two functions. One is going to get the path of this file, process this document, create the vector embedding, store that in a vector DB using Chroma DB, and the next function is going to receive the user's question And based on this question, it's going to look at the vector DB and answer the user's question. So these are the two functions that we are going to create. So we need like the embedding models, LLM, all those things here. So let's see how we can do that. So first I'll import OS, and then I'll import a JSON library. I'll tell you the purpose for that. From LangChain underscore community dot document loaders, import unstructured PDF loader is what we need. Okay, and then from LangChain Hugging Face, or yeah, from LangChain Hugging Face, import Hugging Face embeddings. Right, from LangChain text splitters, import recursive text splitters. Oh, okay, recursive character text splitter is what we need. Okay, and then I'll explain you in a minute the purpose of all these things. Just hang in there. From LangChain Chroma, import Chroma. From LangChain Groq, import chat Groq. Finally, from LangChain underscore chains, oh sorry, LangChain dot chains, import retrieval QA. These are the things that we need. Let's try to understand the purpose of all these things. So first we have OS. The reason we have OS is we are using Groq, so which is a API, right? So we need to call this Groq API. But in order to use that Groq API, we need the API key in order to validate our request. So this API key, we need to get it from Groq site. And once we get this API key, we are going to save that in the environment variable. And this Groq key, we are not going to mention it explicitly in our code, which is not a good practice. So instead, I'm going to create a file, a JSON file called as config.json. So that's why we have this JSON library in order to process that config.json and extract the API key. And later we would store that in the environment variable. So this is a standard approach. And another way of doing this is instead of creating a JSON file, you can also create a .env file and you can put your API key there and use python.env library to load the contents of the environment file to your environment variables. So from there we can securely get the the environment variable, and again from that we are getting our API key. So this is a more secured way and a standard approach instead of mentioning your API key in your code, because it's a secret kind of information, right? So we should never put our key in the code openly. So that's the reason we are importing these two libraries. As you can see, I've imported these two things and given a space over here because these are pre-built libraries. These are the libraries that we have installed from the requirements.txt file. So from here we have a LangChain community.document loaders. We are importing our unstructured PDF loader, which is used to extract all the text content from the PDF file. And then we have LangChain Hugging Face, from where we are importing this Hugging Face embedding, which is the embedding model that's going to transform your text into feature vectors, to your vector embeddings, right? And then you have LangChain text splitters. From there we have this recursive character text splitter, and that's going to split your text into different chunks. Later we would apply like vector embeddings on that. Maybe I'll import this first so that it is kind of consistent with the order that we'd be following. So first unstructured PDF loader, and then we have this Hugging Face, recursive character text splitter, and then we would have this Hugging Face embeddings, and then Chroma, of course, in order to create our vector DB, and then LangChain Groq. From this we call this chat Groq. So here we mentioned the model that we need. So as I said, in this case, we'll be using distilled version of the DeepSeek-R1 model, the 70 billion version, and then we have this LangChain chains retrieval QA. So yeah, which is used to create that retrieval chain that's used to uh, send the document context to the LLM along with the user's question, and the LLM would frame the answer that we need. So we have all these things as expected. So the next thing is we need to get the API key. So I'll create a file over here, right click here and create file, and call this as config.json. So this is a JSON file. So the name that we have to give here is this is something important. You shouldn't give a different name. So Groq underscore API key. Because when you call this chat Groq, right, it's going to look for the API key in this particular environment variable. So this exact name that we have to use. Now we need to get our API key and you know paste it over here. So I'll search for Groq API key. So that's going to open the console. So I'm already signed up and logged in. So if not, you can sign up with Google. So that's going to work. So in this, I've already these particular keys that I've used before. So for this, I'm going to create a new key, and I'll name this as DeepSeek RAG key, so that I can know like what's the purpose of the key, or like whether I need this key anymore or not. So you have to keep these things securely. So I'll close this for now, come back to this config.json and paste it over here. So this is my API key. And now I'll open my RAG utility. Now I have to save this in my environment variable. So what I'm going to do is say working directory. Don't need that. So working directory is equal to os.path dot absolute path file. Okay, so this is something that we need. The reason we are doing this is, as I said, when you run your Streamlit app, when you call this function, it's not going to run from your project directory. Sometimes it runs where your Python executable is installed. So we need to give the entire path of this config.json file. So maybe I'll complete this code that would make more sense to you. So I'll say config data is equal to json.load open f working directory slash config.json. Okay, let's try to understand this. Okay, so this is done basically to read this config.json. Later we would extract this Groq API key, but when you are reading this using this json.load.open, right? So we need to give the path of this config.json. You cannot just mention config.json without the entire path, because as I said, this code will be executed in a different directory. Your working directory would be different. So in order to kind of handle that, we are getting this entire path of this using this os.path.absolute path of file. So what this does is, when you use this os.path.absolute path of file, this is going to find the absolute path of your current file. The current file, this code present is ragutility.py. So this is going to give me the path, or basically like where your file is stored. We also need to say os dot path dot directory name. Okay, and within that we need to have this os dot path dot absolute path. So now when I run this, this is going to give the path of this rag utility, which is basically this path. I can maybe show you this so that it's more clear. I'll comment all these things because we don't need to import these things now. I'll just print and show this working directory, this one. So we are basically, this gives you the absolute path of this file, that is rag utility. From this we don't need the path of this rag utility, but we just need the directory name. So we are using this os.path.directory. So that's going to give the directory where this rag utility is saved. So when I run this, it's going to print this c users set my pc, all this, basically the folder where your rag utility is present. So now I'm going to join this with this working directory config date json. So if I copy this and paste it over here, right, what would happen is, instead of this working directory, if I paste this, so it would give me the path of this config JSON. So I have this DeepSeek RAG Groq DeepSeek thing config.json. So I have this particular path. So we are getting this path, and now we are reading this thing. So instead of copying this absolute path and pasting it over here, we are dynamically getting this. So that's the reason we have it over here. And now once we read this, I can also print and show you the config data. Let's see. See, so this is basically what we are doing here. So instead of copying the entire path, we are finding the working directory and concatenating this with the name of the config.json, and later we can access this Groq API key API keys value, and then we can store it in the environment variable. So that's basically the step that we are doing it. So again, you can do this simply by directly pasting your API key, but as we want to have more standard approach of the code, we are doing this. I'll uncomment all these things and say Groq API key, the same name that we add in our config.json file. So we need to use that as the variable name and say config data. So we need to extract it from the config data variable that we have created, which is going to save your JSON files data. And here mention Groq API key because this is the name of this key, right? So later I'm going to say os.environ Groq API key is equal to Groq API key. So basically what we are doing here is from this config.json, I'm extracting this API key value, storing this to the variable called as Groq API key. And then in the environment variable, I'm creating a variable called as Groq API key and storing its value. So it's like storing or copying and pasting this particular value to your PC's environment variable. So that's the entire process. Because we need this in order to load our Groq model. If you're going with Olama, you don't need all these things because Olama will be running in your local machine. So we don't need that. Okay, so next thing is we need to load our embedding model and the LLM. So I'm going to say loading the embedding model. Embedding is equal to we don't need this Hugging Face embedding that we have imported from here. You can just mention you don't have to mention anything here. If you want a specific embedding model, you can mention the name of the model here, but I can go with the default model, so I don't need this. So load the embedding model, and the next step is we have to load the LLM from Groq. Okay, so now so Grok has a lot of models, right? So it has Llama, Gimmon, and other open source models is available in Grok. So I'll say LLM is equal to chat Grok that we have imported from LangChain Grok. And within this, we need to pass the name of the model. So I'll say model is equal to, so this parameter takes in the name of the model. In order to find the supported models by Grok, you can just go to Google and search for Grok models and you will see the supported model site. And there they have this list of models, the developer, context window. So all these are details are available here. So for us, we'll be using DeepSeek, right? So we have DeepSeek-R1 distilled Llama 70 billion. So this 70 billion DeepSeek-R1 version is the one that we are going to use. So I need to copy this model ID. So model ID is something that we need. So we have the developer as DeepSeek. And if you want to look at this models card, you can open this card. I'm giving this open in a new tab, and we have this DeepSeek's details that's available in Hugging Face. We have the distilled version, like all those things about it, and so on, the benchmarks, all those details. You can go through this if you want. So all I need is the model ID that's present over here. So copy this and pass it to this model variable that we have over here. And you can set up the, parameters that you want. So we have temperature and all other parameters. Just for simplicity, I'll just use temperature for now. Okay, so this is the initiation part. So we have imported all the libraries and then we have imported all the models that we need, which are basically my Hugging Face embedding model, and then which is going to load in my GPU. And then I have chat grok. From chat grok we are loading this DeepSeek-R1's API using this chat grok thing from LangChain grok library. So now let's create those two functions that we need. So the first thing that I'm going to create is process document to chroma db. So we need to process this document. So basically extract the text, chunk it to different chunks, convert it to vector embeddings, and then save it to your vector db, which is chroma db. So all those things that we need to do. So the input parameter that it's going to take is file name. So we don't have to give the path, file name, using this working directory that we already have, right? So we can join this with the name of the file. So from that we can access the file that the user has uploaded. So put a colon here, and here say uh, document, load the document, or yeah, load the document doc using unstructured. So this unstructured library. So I'm going to say loader is equal to unstructured PDF loader that we have imported from LangChain community document loaders. Let me see if it's available in LangChain unstructured because we have imported it. LangChain unstructured. So we have this version. Yeah, we should be able to use this one, but let me check. I'm not sure if it's going to work, but let's see. So copy and paste it over here. So instead of using LangChain community, because we have already installed LangChain unstructured, right? I'm not sure if it's going to work, but let's see. LangChain unstructured. So we have to use the PDF loader. So this should be available over here. It says it's not, cannot find declaration to go to. Okay, maybe I'll just go with the LangChain community version itself for now. If it's not sure if it's in a different name. Yeah, they're still using the LangChain community document loaders for PDF as well. So yeah, I think that's good. Hmm. Seems like they're using this one only. Okay, so we have LangChain community unstructured PDF loader. And within this, mention the path of this file. So I can say f colon, the string that we're going to substitute. So mention your working directory slash file name. So this file name, this should also be a variable. So all this variable name should be passed within this curly braces when you're using a f string that's going to substitute it with the actual values. So this is just similar way of accessing this config data. We cannot just give the name of the file name because the executable can be different. So we mention this entire path by joining the working directory as well as the file name. So the file name we get it from the user. So once the user has uploaded it, right, so we have this uploaded file dot name. So that we are going to pass it to this particular function, and then we later combine it with working directory. You can also give this entire path as well because we are already doing that, but I just like wanted to explain you or you can join this working directory. So I can go with this, but yeah, you can also pass this entire file because we have already created that. Okay, so this is going to load the PDF file using this unstructured PDF loader. And now we have to say documents is equal to loader dot load. Okay, so the next step is splitting the text into chunks. So for this, I'll say text splitter. So we have to create an instance of this recursive character text splitter, and then we need to mention the chunk size and the overlap size. I'll say chunk size is equal to 2000, but again, you can play around with these numbers. I'll just use this things. Chunk overlap is equal to 200. And say text is equal to text splitter. Pass your documents that you have processed. So say text splitter dot split documents, and there pass your documents. Okay, so next is vector db is equal to chroma dot from documents, and then here we need to pass the parameters. So documents is equal to your text that we have created, the text chunks, and then we need to pass the embedding model. So that's going to convert your text data into embedding. So this embedding is the embedding model that we have loaded here, the Hugging Face embedding. And then finally, we need a persist directory. This also we can mention by having this working directory as well as the name. So I want this to be called as doc vector store. So basically when we process this, this is going to create a directory in the same working directory called as doc vector store, and that's going to have all our vector db contents. And then yeah, I think this is the processing part. Return 0. Okay, let's try to understand this. So we call this function from the Streamlit user interface. So once the user has uploaded something, we are going to process this document. And what we are doing here is we have this unstructured PDF loader. So we read this PDF file, giving this entire path over here and storing this. We are loading this using this loader.load. So loader is nothing but your unstructured PDF loader where we have passed our document. And then we have our documents. Basically, all those text data is now extracted. Now we need to split this text data into smaller chunks. for that, we are creating an instance of the recursive character text splitter, and there is also another text splitter called as just a character text splitter. You can use that as well. And here I have a chunk size of 2000 and chunk overlap of 200. Now I have this text splitter dot split documents where we are splitting this based on this particular parameters and storing this in a variable called as text. And now we have this text, so this text need to be converted into vector embeddings, and now we have to store that. So what we do is use this chroma that we have imported from LangChain chroma. So this is the chroma DB method. From documents, we need to pass this thing. So we are passing this raw text. These are not vector embeddings now. These are only like text, right? So these are like letters. So we are passing this text chunks. We are also passing this embeddings, and then the directory where we need this to be stored. So when you call this, this is going to take all these text chunks, use this embedding model that we have imported from here, convert all these text into vector embeddings and store this in the persist directory. So this is what is going to happen in this process document part. So I hope this until this part everything is clear. So I've already made a video on how this rack system would work. If you are not sure about why we are doing this thing, why we are creating a vector DB, how this goes to the LLM and so on, please watch that conceptual video. Maybe I'll try to put that link in the description so that it's easier for you, but you can search it and you will find that video. So I'll just give you a gist of how this entire thing would work. So first, we have a document, right? So the user has given a document, so we extract all the text, create chunks of this text, and then convert it to vector embeddings and store it in a vector DB. Now let's say you have 20 different chunks from your document. Let's say that's what you have. Now the user is asking a question. This question is also converted into a vector embedding, and we do a similarity search for this particular user's question. What can be the possible answer present in the document? So let's say that you have 20 different chunks that are converted into vector embeddings in your vector DB. Now we have the user's question, right? So we try to find out of these 20 chunks which chunks can be possibly the answer. So now let's say the chunk 15 is the answer for the user's question. So we take this 20th chunk, which is now present as vector embedding. But for this particular 15th chunk, we get the corresponding actual text data. What was the text data before, we have saved it in the vector DB. So we could get that. So now we have the user's question in text format and the corresponding related context in the document in the text format. Now you pass these two texts, your user's question in text format and the possibly the content that holds the answer for this question to your LLM, and your LLM is going to frame answer it and it's going to give this. So this is how this entire part works. So your LLM, the main thing that you need to understand here is the LLM is not going to look at the vector embeddings. The LLM cannot understand vector embeddings. Large language models can understand only text, right? So that's the thing. So we are just sending input question as text and the context window as text. Context window is nothing but the part of the document that's related to this user's question. So we send these two things to the LLM, and then now the LLM is able to answer. So all these are kind of handled by this retrieval QA. So getting the user's question, converting it to a vector embedding, and then matching it with the vector DB and then sending it to the LLM. So all these are created or are basically done by this chain called as retrieval QA chain. So similarly, we have conversational retrieval QA chain. So much chains are there, but this is like one of the basic ones. So that's the other thing. So this is the first part, which is just processing the document and storing in the vector DB. So now let's say this part is done. We are creating another function called as answer question. So this part should run once the user has uploaded the document, but this answer question should be done when the user has typed in a question, and after they have clicked on that answer button, we need to call this retrieval QA that's going to use the LLM to answer the question. So we have this define answer question and pass your user question parameter over here. And now we have to load the vector DB. So the previous part we have created the vector DB. Now we have to load the vector DB that we have created. Sorry. Yeah, so load the persistent vector DB by using this doc vector store thing. We can do that. So I'll say vector DB is equal to chroma uh, persist directory. pass this persist directory. So you can pass this. This step is for creating this. This step is for loading this. Okay, so persist directory path, and then we need to pass the embedding. Okay, so embedding is equal to embedding function. Okay, is equal to embedding. This is because we need to convert the user's question into embedding as well. So then only it can do a similarity search on the vector DB. So this question will be converted into a vector embedding. So that's why we need to pass this embedding here. And then we need to create a retriever for this, which we need to pass later to the retrieval QA. So I'll say retriever. Just importing all these things which is not necessary. Okay, so retriever is equal to vector DB dot as retriever. You can pass some keyword arguments, but for us, for a simple use case, that's not necessary. And now let's create a chain to answer user question using DeepSeek R1. Okay, so I'll create a variable called as QA chain is equal to retrieval QA dot from chain type. uh, and we need to pass our LLM is equal to LLM that we have imported, that is your chat Groq DeepSeek-R1 distilled llama 70 billion. And then we have to pass our retriever chain type as well. So chain type is equal to stuff. There are different chain types, you can explore that also. Retriever is equal to the same name retriever that we have created over here, which is the ChromaDB as retriever. If you want to return the source documents, you can do that as well. So it would mention like what's the source of this particular answer, like what are all the source documents. So return source, let me type it. Oh, this shouldn't give me an error, not sure why. Yeah, okay, it's working now, I guess. Okay, return source documents. And finally, we have this response. So this response is equal to QA chain dot invoke and pass your user query as query, user question, and finally answer is equal to response of result. Okay, then we can return our answer. Let's try to understand this. So we call this after the user has given us a question. So we load the vector DB that as the vector embedding of the document that the user has provided us. And then we are creating a retriever from this vector DB that's going to retrieve the relevant context for the user's question. And now we have the QA chain where we are passing the LLM chain type retriever return source documents and finally invoking this. So this is the part where we invoke this chain. So this chain already has the LLM, right? The DeepSeek LLM. So that's where we are passing our user's question, and we have the retriever so on. So it would pass the question as well as the required context window from the document, and that's stored in this response. So we are invoking this QA chain that has this retriever and LLM, and this answer is stored in response of result, and finally you are returning this answer. So now we need to import these two functions in our Streamlit tab. So I'll come back to my main.py. As I said, if you're creating separate modules, give a line space and say from rag utility, which is name of the Python file that we have created, and we have a function based module. So I'll say from rag utility import, first is process documents to ChromaDB, and then next one is answer question. You can create other names as well. It's not mandatory that you need to create these names, so that's up to you. So how this should work is we should automatically process the document once the user has uploaded it. So that means if it is not none, once we save this document, what we have to do is save this over here. So for this, I can say something like uh, for this thing, process documents, I'll create a variable called as process document is equal to process document to ChromaDB, the function that we have over here, and pass your uploaded file dot name. So we know, right? So this uploaded file dot name, this we have already discussed. So this uploaded file is the one that they have imported, but if you want the name, you need to pass this uploaded file dot name. So this process document to ChromaDB requires file name, and then it would concatenate with the entire path, and it would do the other stuff that's required to create the vector DB and so on. And once this processing is done, we are going to say st.info. So this is going to create a blue text box, and within that we can say document processed successfully, so that now the user know that they are free to ask the question. So we have successfully processed our document, so we know that. So for that we are using this st.info that's going to create this blue text box, as I said. And now they have, once this has processed, they can type in their question, and once this answer button has been clicked, we are going to display that. So I can say answer is equal to answer question. So this is the function that we have imported, and the input that it takes is user's question. So the user's question is coming from this particular widget st.text area. So copy and pass this user question over here, and then display it. Say st.markdown. So let's call this DeepSeek R1 response, just a header, and say this, the output is going to come in markdown format. So that's why I'm using markdown. If not, you can use st.write or something to display it, or even st.info or st.success. St.success would display it in a green box. So that's the difference. So say st.markdown and this answer thing. That is all that we need. So what we have done over here is, so we have created the Streamlit app. The user uploads a document, so we save that in this directory and then process it into vector embedding, save that in the ChromaDB, and say document process successfully. Then the user can ask a question, and then they can click on this answer, then they get the answer. So the main thing that's going to happen here is, like, when we start this application for the first time, the embedding model will be loaded. So that's like 200 or 400 MB of size. So that's going to take some time for the first time, but in the upcoming runs, it may not take like that much time. But this is the entire process. So maybe I'll start my application now. So I'll delete this file as well, because let's upload it freshly. So this file should be saved and everything works properly. We should create a folder called as doc vector store that should hold the vector DBs. Let's see if it works. If there are any issues, we can debug and try to figure that out. So say streamlit run main.py, which is the streamlit code. So this should open the browser, as we can see over here. So it says running. It's taking some time because the embedding model and other stuff kind of gets imported when you try to import this drag utility. So that's why we have this. You can see, so the embedding model is getting imported. So it's still a white page. So for the first time you would see this, as I said, but later this may not happen. Okay, so it's like about 432 MB of size. So the model is almost pulled. Maybe let's open our web page and wait for it. Let me close this. Okay. So the network is also a bit slow. So if not, you would probably like get it a bit faster. So now you can see now our app is loaded. So if you want to, not want to have this waiting time when someone opens your app, is what you can do is, you can have two places where in one part you have your Streamlit code running, and all these functions and other stuff you can deploy it as API. So what I would do is I would create another project specifically for API. So instead of calling this function, I would call this process document function and the question answer function, that API. So that, like, the API would have already loaded the embedding model. So everything is there. User interface is only like handling the front end part. So the model loading time, all those things open here. So that's like a good architecture. So you have your Streamlit app code in a separate environment just for the user interface, and the model calling part, the part where your document is getting processed, so that can go to a API environment. So that's something that you can do. You can also use Flask or Fast API to do that. Okay, so about that in a different video probably, but yeah. So now we have our application, so we didn't get any issues still. I'll click on this browse files, I'll upload this, attention is all you need. So now once I upload this, so it should process this document. First it should save this file. As we can see, the file is saved. Now it should kind of save this in a vector database, so you can see it is running. So once everything is done in this document processing part, we should see a blue bar and text in it saying that document processed successfully. As you can see, document processed successfully, because we have added this st.info, right? So once the document has been processed, we need to see that. And now you can also see we have a folder created called doc vector store that has all those vector db contents in it. So now let's say the user is asking a question. So I'll say, what does the document say about transformer architecture? So this is a reasoning model. So it's going to kind of have this chain of thoughts and try to come up with the answer that's more detailed than what you would get from a, let's say, Llama 70 billion or Chat GPT 4.0. But if you try this in a Chat GPT 0.1 model, which is a reasoning model, you would kind of get something like that. We get a error saying that vector store pedantic validated. Okay, there is some issue. Let's see what's happening here. Be a valid string. I'll open this. Oh, sorry. So we have this vector store similarity search query. User's question. Okay. Answer question. Invoke this user's question and then okay. Oh, get retrieval. Okay, I think this is the issue, but let's see if this is the one that's creating that. Not sure, but I'll remove this retrieve return source documents for now. Okay. Similarity search itself is giving an issue. Okay. So you can come back here and refresh this. So that's going to update the code. See, now it's not taken like a long time to load. What does the document say about uh, architecture? Let me save this somewhere so that I can use this later. Create a new notepad, save this here. Okay, let's click on this answer. I guess we may get this error again. Let's try to debug this. Oh, now we got this. Probably like there was some issue in return source documents thing. Okay, I think now it worked. Yeah, so this is the error from the previous time we asked the question, but now it was able to say this. Yeah, okay, so we have displayed this in Markdown. You can again ask a different questions like explain in detail about, or I'll just like remove this architecture thing. Let's see. So we have already processed this document, so we don't have to run that again. So now I'll click on this answer again. So let's see. So return source document should work, but maybe I can look into like what's happening there and see like what's the issue. Okay, so this is the model's response. It says think, okay, so I need to figure out what the document says about the transformer model. Let me start by reading through provided context carefully. So we have like all those explanation. Maybe you can go through this. So this is the first part where the model is trying to understand the context. Then it says that this is the actual response, actual final answer that the LLM is trying to give us. The document discuss the transformer model focusing on its configuration and training, details, use of base, big models, and so on. So we have all this, thing and so on. So how this would work is like this is different from uh, how a normal LLM would work. As this is a reasoning model, it would have this chain of thoughts, try to look at this question and the document context and try to come up with like the proper response. So this is how different LLM is compared to a LLM. Again, that's a reasoning model. So you can just try asking different questions, and you can also try this with different documents and try to ask some questions that could test the model's capability of reasoning. So here you can see, right? So it also is able to carefully mention as like what's the thought process. So it says that first it needs to go through the context, understand this clearly, and do this. So there is a step by step process where the model is able to do this. So this is the first step of the model doing all this tasks, and then finally we have this response. So as I said, try to upload other documents as well and try to ask questions that is able to test the model's capability. But this is how you can create this entire system. So yeah, other things worked as expected. So what we did is uh, we have this RAG utility module that has the process document part, and then we have this answer question part, and then we are using this DeepSeek-R1 digital LLM 70 billion version from Groq to basically answer this. So the first part is once the user has uploaded the document, so we extract the text, convert it into vector embeddings, and store that to ChromaDB, which is our vector database. And then once the user has asked the question, we pass that to the LangChain retrieval QA chain along with the LLM and the retriever, and the LLM would come up with the response given the document context as well. So I hope everyone is clear with this. So I'll share the link for this particular code base with you so you can try this out. And yeah, that's it from my side, and I'll see you in the next upload. Thanks for watching.